Okay, it's been a while since I've made a video, and to the disappointment of a few people, this one's not going to be about making the knight for the chess set. I want to go over another heavily misunderstood and mostly unused tool. And that tool is the curve tool, which lives within loop tools. Now, the process we're going to use is generally called cubic interpolation, but it's more commonly referred to as panel beating, as in the type of work a car mechanic might do to work out the surfaces of a damaged metal panel from a car. So let's get started. So if I just delete the default cube, I'm going to press Shift and A to add a mesh plane. I'm going to move the camera forward, tab into edit mode, and subdivide that, let's say 4 times. 2, 3, 4. Good, so we've got this grid, and what you'll see people doing is, along one of the edges, they'll select a vertex, or more than one, I'll just use one point here, and they'll move it. So I'll press G, and I'm going to press Y so that it just moves along the Y-axis, and I'm going to move it out a little bit. Doesn't matter where. Now I can select this corner point, Shift and select the point I moved, and then Shift and select another one at the other end of this loop. It doesn't matter which order you select the points in. If I now press N to bring up the N panel and go to the Edit tab where my loop tools live, I can press Curve, and we can see that this edge is transformed into a curve between our 3 selected points. I'm sure you've seen that before. That's how everyone seems to use the curve tool in loop tools, and they never go beyond that. And I guess that's useful, but that's not really what we use the curve tool to do. It's much more powerful than that. Let me just undo a few steps and I'll talk about how it works on this simple flat grid. Actually, first of all, let's look at how I often see people trying to curve a surface like this, and we can see some of the problems. If I click this little circle up here at the top of the 3D view, we can turn on proportional editing. And then I'll go to the grid and grab a point somewhere in the middle, and I can just press G and Z to move it up and down, and you can see this curvature being created across the surface. And this tool is using the circle you can see around it, to decide how many points it encompasses on the mesh to create this curvature. It's a great tool, and you'll see me using it all the time in other videos. But it has some problems. Firstly, the shape of the area that we're moving is decided by this circle, and it's always a circle. That can't be changed, and that's quite a big problem. When I scroll my mouse up and down to change the size of the circle, I can make it quite large. You can see that the edges of our mesh are being pulled up, and we very rarely want this to happen. Or if we do, we want much more control than this. Proportional editing is powerful, but it's very limited. There's a much better way to curve a surface. So let's just undo this and start to change the curvature using the curve tool. So first of all, I'm going to turn off proportional editing. We won't be using that. And again, I'm going to select a point in the middle and move it up in Z. So just press G and Z and move the mouse. And this time it's the only point that moves. And what we're describing here is the peak or the apex of the curvature we want to achieve. So I've moved this point up, but we want the whole surface to match this peak. And I do that by selecting the 2 points at the very edge of the same loop that our moved point is on, in either direction. I'm going to do it from left to right, but you could go from top to bottom too. So I have a point to the left, the point we've moved, and a point to the right, all on the same loop. And I can now go over to the N panel and press the curve button. And it's just the same effect that we saw at the edge, but now we're doing it in the middle of the mesh. And it creates this ridge, which has been created by moving the unselected vertices into positions between the ones we do have selected. And that's the important thing to understand at this point. The curve tool works only on unselected vertices. So, we've made this ridge. It's not really what we wanted, but the next thing you need to understand is that the curve tool is designed to work between loops, not just between vertices. That's why it's in loop tools. So now I can Alt and click on this loop at the bottom to select the whole thing, Shift Alt and click on the loop at the top, and finally Shift Alt and click our curved loop in the middle. And now when I press the curve button in the N panel, we'll see that the whole surface has now been curved to match the single point that we originally moved. But very importantly, all the vertices around the edge are in exactly the same place they were when they started, unlike the mesh we ended up with when we used the proportional editing tool, which pulled up those edges and all the vertices with it. We've decided on the limits of the curvature ourselves, and this is a really important distinction. So this is getting a little more useful, and we do use this functionality a lot, but it's still not really what you'll use the curve tool for most of the time. The main use, when you're starting out using it anyway, is to fix problems on a surface. And we can use this newly curved grid to talk about that. Let's say we had some points selected on this mesh and we were moving them around to shape it. It doesn't really matter which ones or how many or where we move them to. I'll just select these 2 here, and I'll move them up in Z to make these bumps, and maybe I'll scale them out in Y. And we've created this feature on our fairly complicated curved surface. And that's great, but what if I now moved some points somewhere else on the mesh? I'll just select a few over here, and I'll move them up in Z and maybe back in X. I'll scale them in Y, whatever you're doing to make your shape. And all of a sudden, while we're working, we decide that we really like this area here, but we don't like these two bumps anymore. What can we do to get rid of them? Well, it's really difficult to move them back into place, or to smooth them out, or average them, or rebuild them. Without the surface becoming very flat or too curved, you will always end up with bumps and errors around this area. We can't use undo because we like this part of the back, and pressing undo would get rid of that. We may have done hundreds of other modelling changes since we decided we just don't like these, and we don't want to have to undo all that work. But we need to get rid of them, and the curve tool is used to do just that. What we do is we select the points we don't like, then we press Ctrl and I to invert the selection so that the rest of the mesh is selected and our problem points are unselected. And remember that I said the curve tool only works on unselected vertices. So if we press the curve tool at this point, then Blender will rebuild the curvature using these unselected points, but with respect to all of the curvature surrounding it. And that's all calculated cubically, which effectively makes the continuity perfect. And that is really impossible to do any other way. And maybe I didn't want to get rid of those features completely, just reduce their size. Well, again, that's possible with the influence slider in the properties box down here. As we move this, we can see we can actually reduce the magnitude of a feature, always with absolute respect for the curvature around it. So things can easily be reduced in size, or eliminated altogether. And we can continue shaping this surface and making changes, and we will always have the ability to reduce or remove features as we want. Just selecting a few points we don't like, then pressing Ctrl and I to invert the selection and use the curve button. There are all sorts of reasons vertices can be moved out of place on a mesh, and with the curve tool, it's very easy to rebuild complex curvature. It actually works very well as just a flattening tool itself. If I select the two loops at either side of this mesh and press the curve button, the whole thing is flattened down. Or if I want, just reduced in magnitude by using the influence slider. And this method's great for altering and fixing curvature on spheres, cylinders, toruses, any kind of curving shape really. So well, let's show you. Let's just start a new scene. I'm going to delete the default cube and press Shift and A to add a mesh torus. I'm going to set it to shade smooth and press Ctrl and 2 to add a subdivision surface modifier to it. In fact, let's make it even more difficult to work with. I'm going to go over to the modifier panel here and add a simple deform modifier. I'll leave it as bending, but I might increase the bending value, and if I apply this modifier and then tab into edit mode, you can see we have a really complicated curved base mesh. This is the kind of curvature which can make modelers really nervous about making changes, as it seems very difficult to reverse or reduce your changes. But we really don't need to worry. A mistake often made when working with a mesh is that vertices get moved by accident. I might have at some point selected, let's say, 3 vertices here, and they get moved somewhere by accident. And the camera's facing the wrong way to see them, and you might keep working away. It happens to everyone. It happens to me all the time. I should probably be more careful, but it's not as big a problem as you might think. But anyway, you keep working away. Maybe I've selected a loop around the top, and well, let's make something quickly. I might use checker deselect, and I'm going to have 7 deselected vertices for every one that is selected around this loop. And you always need to enter -1 for the offset in checker deselect. I talk about that in another video, so I won't go over it again here, but you do. So always change that to -1. And let's say I expand these points out to create these little islands at the top, just by pressing Ctrl and plus. Maybe I'll move these up a little, and then I'll press Ctrl and minus and just move the original inner point up and maybe scale that out. Whatever you're doing to create your models. And then I've got my shape, and I spin the camera around to look at my handiwork, and suddenly I see these vertices here. It's not part of my design, it's just a mistake. And now our mesh is really very complicated. To put these vertices back into place is virtually impossible. You can try to delete them and rebuild the geometry with new faces or smooth them out somehow, but it's never going to work properly. There are always going to be problems in that area, unless we use the curve tool. So again, I just select the vertices that are incorrectly positioned. I'm going to press Ctrl and I to invert the selection, leaving everything other than these 3 problem vertices selected. Now I press the curve tool and our problem's gone. It's as simple as that. All the curvature has been rebuilt correctly. Light will flow over this surface perfectly because all the calculations are cubic, and that's why we call it cubic interpolation. Mostly we do call it panel beating, but it is actually cubic interpolation. And again, I could just use it to reduce the size of some features on my mesh. Maybe I wanted these 2 pointed shapes here to be smaller than the others. I'm going to press Ctrl and plus to encompass all of the moved points within the selection. Then I press Ctrl and I to invert the selection, hit curve, and of course they're gone. but I can just use the influence slider until they are the size I want them to be. Maybe that's all I wanted to do, just bring them back to this smaller magnitude. Or I might have done all this work and decided I don't like any of it, but I do like the underlying curved torus base mesh. So again, I go around selecting all the top points, press Ctrl and plus, and then Ctrl and I to invert the selection. I'm going to hit curve and make sure the influence sliders are 100%, and all that detail is gone, with this really very complicated curvature around this warped torus rebuilt perfectly. Light will flow over this very smoothly. So that's one very powerful use of the curve tool. Now, another use of the curve tool is when making vehicles, spaceships, the hulls of boats, guns, all sorts of sci-fi objects. It's used extensively in character modeling. In this context, it becomes a modeling tool rather than a repair tool, and you'll find it to be excellent at creating complex curvature on top of other complex curvature. So let's start a new scene, and I'm going to quickly try to show you how panel beating is used to do this kind of thing. I'm going to delete the default cube, I'm going to press Shift and A to add a new mesh plane, I'm going to right click to set it to shade smooth, and I'm going to press Ctrl and 3 to add a subdivision surface modifier to it. I'll tab into edit mode, and I'm going to scale this panel by pressing S, I'll type 2 and press Y, just to scale it along the Y axis. Now we'll need some geometry to work with, so I'm going to press Ctrl and R to add loop cuts. I'm going to hover over this top edge here and type 20 and hit enter to give it more divisions. I'll press Ctrl and R again, and this time I'm going to hover over an edge at the side. I'll type 10 and hit enter, and we end up with what seems like a good enough geometry for a couple of door panels, so I'll go with that. And you'd often be working with a reference or a blueprint. I don't have one. I'm just going to try to quickly show you the general principle of how it works. Anyway, you'd be matching these things with a blueprint. And to do that, we might select a point somewhere in the middle here, and I'll just press G to start moving it. And I'm going to press Shift and Z so that it moves on the same plane. And I'll just move this up here. I might move this point on the corner in the same way to match our imaginary blueprint. And I'll move this one at the other corner too. And then I'll start using our curve tool again. I'll select the left corner point, then the center point that we moved, and then the right side corner point. Make sure the air tab at the end panel is displayed and press curve. And that'll create the curve, which you just have to assume would match our blueprint or reference image. Then I might do the same along this edge. I'll just move a point out near the middle a little. I'll move the one at the bottom corner, just for the sake of it. Select these 3 points and press curve again to make this curved edge. Maybe I'll just move the other corner at the other side and just select 3 points which will describe my curve at the bottom. I'll add a final curve at the side here just so everything flows. Select these 3 points and press curve. And that's great. Maybe that'll be the shape of the car panels from the blueprint or the reference we're working on. But you'll notice that the grid in the middle doesn't match the flow of the overall shape. And again, we use the curve tool to solve this. I'll Alt and click on the bottom row to select this loop. I'll Shift Alt and click one in the middle. And I'll Shift Alt and click a third time to select the loop at the top. Now, when I press curve, it spreads the geometry correctly between these loops. I have to do it from left to right as well. So I'll Alt and click this loop at the side, Shift Alt and click this one around the middle, and Shift Alt and click one on the right. I'll press the curve tool, and you can see now that the internal grid matches the shape very well. But if I move the camera around this panel, it looks very flat, and we wouldn't want that. Nothing is really flat in real life, and certainly not car panels. So maybe I'd select a point in the middle and move it up. I'll press G and Z just to move it up a little. And as I showed you at the start of the video, we can use this peak to curve the whole surface by selecting a point at the edge, the point we moved, and a point at the other edge, and just press curve to create this ridge. Now I'll select the whole loop at the bottom, the whole loop at the top, and the whole loop with the ridge. It doesn't matter which order you select the loops in. And I'll press curve again. And now the whole surface is curved, as a car panel might be, with good topological flow over the surface and perfect continuity for reflections and transparency. I might want to move the corner points down, so I'll select the 4 of them, and I'll just move them down in Z, and that means recurving the surface, and I'll do it by recurving the edges first. I'll select these 3 points and press curve, and then I'll go to the other side. I might even want to move a point up here and curve between these 3. We can have some really complex curvature. Now I want the whole surface to match up, so I'll select the first edge loop at this side, and then one in the middle around the apex of the surface, and then the new curve point on the right. Press curve, and we got some great curvature. You can keep on moving points and recurving to get these shapes you need, but I think this will do for the main surface. Now, I said that you would often want curvature on top of your curvature, so let's do that. So I take a point of the edge here and move it up, and then maybe one further along this loop and move that up. I can select both of these moved vertices, and then I might want this detail to disappear into the original curved surface. So I select a few points at the edge. This will make the new curvature curve perfectly back into the panel surface because all the calculations are cubic. So I press the curve button and there it is. Maybe this is too high, and if I felt that was the case, I can select this entire loop, press Ctrl and plus a few times to select the surrounding loops, and then I Ctrl Alt and click the ridge loop here, and I press curve. When you do it like this, just selecting a few loops, you need to check the boundary box to make sure everything else around the mesh doesn't move, because it can. So that makes it disappear, as it did when we were fixing surfaces with the curve tool. But I can bring it back with the influence slider, make it the height I want, and the relationship between all of the curves is being calculated cubically, so the continuity is always perfect. Okay, that looks fine. Now I might want a much sharper detail, and again, if you look at modern cars, you'll see this everywhere, on almost every car. I'll select a loop here and press Ctrl and B to bevel it. I'm going to roll my mouse so that there are 3 loops. I'm going to move it to around here, and I'll do the same kind of thing again. I'm going to select 2 points in this middle loop here and just move them up a little. Then again, I'm going to select a few down at the other end to taper the curve off into our curved panel. Remember that the selected points won't move at all. And press curve, and now you can see this sharper detail running across the panel. And once you start playing with the curve tool, you can see that there are lots of interesting shapes that can be made to match kind of modern manufacturing processes. Okay, so once my main surface is done, I would normally take a copy of this mesh to use as a shrink wrapping target when I cut holes and things and add other details. But I won't do that here. This is just a really quick demo of panel beating. But yeah, maybe I would want to add some windows now, so I'm just going to select a face here, then Control Shift and select one down here to create this rectangular selection. I'm going to Shift and click a face here, and then Control Shift and click another one here, and I've got 2 kind of vague window shapes. If I now press I to inset that, I would normally turn on Edge Rail for this kind of inset, which keeps everything running along the existing flow of my mesh. I can delete or even separate these polygons out to use as glass for my windows with exactly the right curvature. So I'll press P this time actually to keep those, as they'll probably be useful later, and choose By Selection. And then you can see them here as a new object in the outliner. So I would rename those to windows. It's always a good idea to rename your objects as you go. And I'll just hide them. I won't use them here. That's just to show you how easy it is to make useful elements. So if I select our big panel again and go into edit mode, I can shape the windows now with this loop. I'll just do something simple to one of the windows so you can see how easy it is. I'll select the whole loop, deselect a few points on it, and use the curve tool again. I may need to check or uncheck boundaries. You'll get used to doing that. And you can see we have this curving at the back. And I can shape the windows very easily with the curve tool. This is where I would normally use a shrink wrap modifier with the original base mesh, but I've not done that here for simplicity and speed. Now, I did want this to be 2 doors, so I'm going to select a loop where I want to split them up and bevel that by pressing Ctrl and B and just make it, I don't know, about this wide. Now, if I select the very center loop, I want to select everything on just one side. There are lots of ways to do that, but a quick and simple method is just to go to Select, Select Loops, and Select Loop Inner Region, and that just selects all of the vertices on one side. Now, if I press P to separate it into a new object and choose Selection, we have these 2 door panels. I won't rename them this time. But if I have them both selected and go into edit mode, I can press A to select everything, and then E to extrude. And I'm going to extrude a little further than I normally would, just so we can see what's happening. And what we end up with is this very complex curved pair of panels with perfect continuity between them, with curved detail on top of the curvature, which runs, again, perfectly between them. And they're 2 completely separate objects, so the door can open or fly off, whatever you need. And when they do close, they fit together like a jigsaw. And I would now start adding other furniture like mirrors and door handles and keyholes and all sorts of other modelling techniques for use for that, but that's for further videos. What I hope I've shown you here is that the curve tool is one of the most powerful tools in Blender when working on quad-based meshes which need to curve as they do in real life. So let me see what else I have in here. These sunglasses, they would have been virtually impossible to make without the use of the curve tool. There's really quite a lot going on there. But the curve tool makes this kind of modelling much simpler. And this is very similar to the way NURBS work, because they're also calculated cubically. But in subdivision surface modelling, we have more options, so it's better for our needs in Blender to use the curve tool. This toy train steam engine, It was relatively simple to make because I could play with the surface a lot with the curve tool to experiment with details and change all the curvature to match perfect around all the little features that I add and remove. And it's tools like these that are one of the multitude of reasons to maintain good quad topology on your objects while you're modelling. They won't work at all on meshes that have used the Boolean operators. They won't work with n-gons or triangles or extraordinary poles. You lose access to the more powerful modelling tools in Blender once you start using a Boolean. I can spot a sci-fi model made with what people are calling hard surface Boolean techniques a mile off, and so will you when you start playing with these kind of real modelling tools. Let me just load up a version of this train with just two simple modifiers on it, and you can see that distortion and animation work incredibly well. I can just increase the height in this wave modifier over here, and the topology handles the distortion with ease. And these modifiers may not just be for animation, I might be using them as modelling tools, because I can, because it's all been made with quads, and certainly no Booleans. Under this I've got a simple deform and I can just play with the angle while it's playing back, and there are many times when a model will need to be changed or updated in its life cycle. We're always looking to create something called the framework mesh for any given model. Oh, it's our knight, which I haven't shown you how to make yet. Sorry about that. I haven't really talked about the framework mesh yet. But on the left here we have what might be the framework mesh for this model, and it would always be all in quads. You need to understand that there'll be lots of versions of a model, and some will be triangulated and some versions will have n-gons, depending on the destination, the usage and the rendering technologies used to display them. But all of these different versions will be derived from the framework mesh. That's the main model, and it'll always be quads, and it'll always be as easy to edit and change as possible, and that means good quad topology. When you hear people arguing that everything is triangulated at render time anyway, so it doesn't matter, well, they are correct of course, but that's not the point at all. The point is that if a production or a game is remastered or rebooted or redesigned in any way, then the original models need to be adaptable. If it costs a lot of money and time to change a model, then the people who pay the bills will not be happy. And framework meshes are often quads just for that reason alone. So that's the goal of modelling, to make this framework mesh for any given model. Maybe Unity or Unreal or Godot or VFX or 3D printing, they'll all have different requirements and triangulations and even n-gons. And you'll often need to make all of these versions, and they'll all come from this one framework mesh, using triangulation and decimation techniques. Anyway, that's probably enough of that. I was really just talking about panel beating in this video, and hopefully I've given you a good starting understanding of it. I did miss out a few unrelated modelling steps that would normally be done, but the video would have just been too long if I'd covered all the unrelated stuff, so I think that's enough for now. Now, I'm not really completely well at the moment, so making these videos is a bit of a mountain to climb, but I will get a video made for the night for the chess set. There may be one or two more in between, but I will get there, I promise. And by the time we're done, you should have some really good professional modelling techniques under your belt, which will make you a much better all-round modeler. Okay, well, thanks for watching. See you next time.